Today we're going to talk more about translations, but this time we're going to add the vectors. We spoke once before about vectors, and today we'll learn a little bit more. I had mentioned that a vector is an arrow that indicates size and direction. Here it says a vector is a segment indicating direction of a translation. It has an initial point, which means a starting point, and an end point, with an arrow that indicates direction. So remember, a vector indicates two things: the direction and distance of a translation. Here we have a picture of two such vectors, RS and BC. Look at RS. The arrow is at S right here, which means R is the end point. So this translation is going to go from R to S. It's going to slide a figure from R to S. It's going to go in this direction. It's going to go this distance. Vector BC starts at B. I know that because it doesn't have the arrow. C does. So it's going to start at B and slide to C in this direction, this distance. When we write the names of these, we write it like this. The endpoint gets listed first. Vector RS starts with R and ends with S. Vector BC starts at B and ends at C. The first letter of the vector indicates the endpoint. And on the top, we just write a little arrow, indicating that it's a vector. Moving the page up, we'll have a graph where we will translate triangle ABC by vector DW. DW means we start at D and we go to W. We're going to translate from D to W. In this direction, this length. Let's figure out exactly where we have to move. That means that we're going to go from D over and down to W. Each one of the vertices on triangle ABC will move 1, 2 to the left, and 1, 2, 3, 4 down. That would be T of, if I go to the left, that's -2. And if I'm moving 4 down, it's a -4. Let's do that with each vertex. I'm going to take A and I'm going to go 2 to the left, 1, 2, and 4 down. 1, 2, 3, 4. Make a point, which will be A prime. You can do that on your paper at the same time. Now I'm going to do that with B. 2 to the left and 4 down to mark B prime. You can do that on your paper. And let's move C. 2 to the left, 4 down to mark C prime. Take your straight edge and connect B. Oh, that's not a straight edge. Let's fix that. Connect A to B, C, back to B to C. So I've created triangle A prime, B prime, C prime, which is the translation of triangle ABC. And you can tell it looks like triangle ABC was just translated in this direction. There you go. Next page. Represent the translation using a vector. Looking at the graph, I can see that this figure, which is an arrow, figure A, was translated in this direction to A prime. To figure out exactly how it was translated, I need to take one corner or vertex, this corner, or this corner, this corner, this corner, a point which I can name, and move it up and over to its corresponding corner on A prime. I'm going to take the lower right corner, and I'm going to figure out how many up and over I need to move to get to its corresponding lower right corner. You could do this with any one of the vertices. I could take the top corner and move it to the corresponding top corner, or the lower left corner and move it to the corresponding lower left. I'm just going to go from the lower right to the lower right. Up 1, 2, and over 1, 2, and over 1, 2, 3, 4, 5. So if I wrote that in transformation notation, I went up 2 and to the right 5. Moving in the x direction, it's a positive 5. Moving in the y direction, now we know it's we know it's t, 5, 2. We can write the vector connecting two vertices, or we could write the vector anywhere on the graph. We know it went up 2 and to the right 5. We could draw the vector here. We could start here, go up 2 and to the right 5. 1, 2, 3, 4, 5. And we could connect the points. We could actually use a line if we wanted. Let's be fancy and use a line. Oh, it wasn't fancy enough. Oh well. And make an arrow. There we go. So the vector can be placed anywhere on the grid as long as it represents the move of the translation. In this case, up 2 and to the right 5. Or it could just connect two corresponding vertices. Let's go to the next page. On this page, which vector represents the translation shown? So we have to figure out which vector represents us going from rectangle S to rectangle S prime. Let's see if we can first narrow it down. We have vector FH. I know it starts at F and goes to H because the arrow is at H. In the next vector, the arrow is at A, so it's CA. Well, right away I can tell it's not going to be that vector. It's not this one. Can't be that one because we are going from S to S prime. We're heading down, and this vector is going up. This vector starts at B and goes to Q because the arrow is at Q. My choice is now either vector FH or vector BQ. Figure it out. I'm going to do what I did on the last page. I'm going to connect two corresponding vertices. I'm going to connect this top left vertex to its corresponding top left vertex. And I'm going to count how many over and how many down I need to move. From here I need to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the left, and 1, 2, 3, 4, 5 down. If I represent that just for now in transformation notation, that was 10 to the left and 5 down, so that would be a negative 10, and 1, 2, 3, 4, 5 down, negative 5. So I have to figure out which one of these vectors moves 10 to the left. I think we can tell by looking, but we're just going to double check. This vector moves 1, 2, 3, 4. That can't be it. This vector moves 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is going to be the vector 1, 2, 3, 4, 5. So our answer is vector. Remember, we start with the beginning letter. So it's vector BQ. And then we draw an arrow on the top. That's it. Vector BQ. Any questions? No questions? Then we're done. Hope you enjoyed the lesson.